All right, this is a review for the Chapter 3 Algebra test. I have printed a copy of the 3.09 practice test right here, and I'm going to work through it and talk about how to solve each problem. And so that way, if you're not sure how to solve some of these, this should help you. Pardon me. All right, let's look at number one. The equation below represents function A. So this is function A, and the graph is function B right here. Which equation best compares the slopes of the two functions? So we want to know if they're equal, if B is twice as big as A is twice as big as B, or B is the negative of slope A. So we need to know what our slope is. Well, in a y equals mx plus b equation, the m is our slope. So that means in this, our slope is -2. -2. Let's do it. -2 for function A. Function B, let's see, it's hard to see those lines. They're not printed very good, but it crosses a line there. There's a point right there that goes across. There's a point across. So it goes up 2 and over 1. Slope on a graph is rise over run. So it rises 2, runs 1. So that's a slope of 2. This is a slope of -2. This is a slope of 2. So slope of B is the opposite of slope A. There we go. Number one out of the way. Let's look at number two. The location of an ant from a tree is 3 meters west. West, so let's say in negative direction, right? Because east, west, north, south, negative direction. The ant walked towards the tree at a constant rate, so that means linear, and reached the tree in 2 minutes. So 2 minutes, 3 meters. If y represents the location of the ant, so y is location, like 3 meters, and x is time. So our minutes is the x-axis. Which graph best represents this equation? Okay, so it started at -3, because 3 meters west, and it took 2 minutes. So -3, and this is on the y, because we're talking about the y, and 2 minutes. So we need one that the x goes for 2 minutes. This x went 1, 2, 3 minutes. This x went 1, 2, 3 minutes. Let's look at the other choices. This x went 1, 2, and it started at y equals -3 and went to y equals 0. That's got to be our selection right there. This one goes 3 minutes, 1, 2, 3, and goes 2 meters. So this is the graph that represents it. We check the circle over there for that one. Okay, given the function f of x equals 2 times x plus 10, find x if f of x equals 24. So this equals 24. 24 equals 2 times x plus 10. It didn't say x equaled 24. It said f of x equals 24. So we have to solve this. Well, remember our order of operations. All right, order of operations. 24 equals 2 times x is 2x. 2 times 10 is a positive 20. Subtract 20 from both sides. 4 equals 2x, and then when you divide 2, x equals 2. Right there. X equals 2. All right. Choose the equation of the vertical line. Vertical is up and down. This is horizontal, because think of horizon. When you scan the horizon, when you're standing scanning the horizon, you're looking left to right. The horizon like that. Horizontal, vertical. So vertical line passing through the point -4, 2. Well, if it's going like this on a graph, if we had this on a graph, it'd be where all like x's are the same. The y's change because 1, 2, 3, 4, the y changed all of it, but the x stays the same. So this is an x equals. Well, what is the x for this point? The x is -4. So this would be over at 1, 2, 3, 4. It's got to be a vertical line going through -4. So which equation would that be? That would be x equals -4. Because right there, doesn't matter what the y is, the x always equals -4. Always. -4, -4, -4, 0, -4, 1, -4, 28. X always equals -4. So vertical lines are x equals. Horizontal lines are y equals. I'd write these in my notes and have them for the test. I can't remember. Which of the following does not represent a function? Well, a function is where every x value only has one y value. So right here, when the x is 4, there's one y right there. When the x is 8, there's one y right there. When the x is 0, there's one y right there. So on a graph, you can do the vertical line test. If I make a straight up and down line, does it touch the graph more than once? There's where the graph of the line. It only touches it once, no matter where my vertical line is. Oh, look at there. It touched it twice. So when x equals -4, it has a y of 1 and it has a y of -1. This x got greedy. That x got greedy and got two y's. This one is only one. Doesn't matter where we make a line. So this third one is not a function because these x's here, when x is 0, it grabbed two y's. It's got 3 and -3. These x's are getting greedy here and taking more than one y. Not a function. Easy to tell in the graph. Just vertical line, if it touches it more than once, not a function. All right, choose the equation below that represents the line passing through the point 2, -4 with a slope of 1/2. All right, slope of 1/2. So all of these have a slope of 1/2. All of them do. And the point 2, -4. Well, you can play around with a lot of these, and you can substitute -4 for the y, and you can substitute 2 for the x and see which ones are true. That's one way you can do it, because we would say, if you want to try it that way, -4 equals 1/2 x minus 3. Oh, sorry, the x is going to be a 2 because we're putting this point in. 2. So -4 equals 1/2 times 2 is 1 minus 3. -4 equals 1 minus 3 is -2. -4 equals -2. That's not true. It does not equal. So it can't be the first one. The other thing we can do with that is we can use the point slope equation and convert it. Point slope equation is y minus the y value. We'll call it y1. This would be x1, y1 equals the slope x minus the x value, which for our equation would be y minus, that's -4. So y minus -4, so we can rewrite that as y plus 4, because when you subtract a negative, it becomes a positive, equals, m is the slope, our slope is 1/2, x minus the x value, x minus 2. So if we do that and put it in this form where the y is by itself, we go y plus 4 equals, parentheses first, 1/2 times x is 1/2 x. 1/2 times -2 is -1. So we've got this equation. Now we subtract 4 from both sides. So y equals 1/2 x. -1 minus 4 more, -5. It's that one. That's the one. But again, we could also take this x and y and substitute it into each equation until we found one to where the left equaled the right, because that would also work. Which of the following statements best describes the effect of replacing the graph of fx, whatever the graph is, with the graph of fx minus 3? So if you got a graph, let's say the graph went right there, right? Whatever it looks like, could be that, right? Could be any graph. And we're going to take the exact same graph and we're just going to subtract 3 from it. Well, that means it's going to be right here instead. If this is your xy axis and this is the point where y equals 3. 1, 2, 3, and this is 0. Subtracting 3 would move the entire graph down 3. The graph shifts 3 units down. Because whatever the graph equals, f of x is the same thing as y. Those are the same thing. Because when we write an equation, when we say y equals 2x plus 1, we could also say f of x equals 2x plus 1, because this is function notation. This is function notation. So these are the same thing, the y and f of x. So if we're subtracting whatever the y is, the y minus 3, it means it's going to come down 3 on the y-axis. So it's going to shift 3 down. All right, let's look at number 8. Okay, the graph below plots a function. We know it's true because if we drew a line anywhere, it would only touch that one time. If x represents time, so this is time, the average rate of change in the function in the first 2 seconds. So here's right there, 2 seconds goes to right there. So what is the average rate of change? Well, rate of change is the same as the slope. How much is it changing? At what rate? So it starts at 50. So we're at 50. And it ends up at 100. Goes to 100. So how much did it change? The y changed from 100 minus 50. And the x changed from 2 seconds minus 0 seconds. So the y changed a total of 50 in 2 seconds. Right? It went from 50 to 100. 50 divided by 2. 50 over half is 25. So the average rate of change is 25. There's a blank there. We have to write that one in. For every 1 second, the rate of change, the slope is for every 1 that the x changes, which would be from here to here. What happened here? That went up 25. So it's just asking for the slope. Rate of change equals slope. That is the slope. All right, choose the equation of the horizontal line, horizon, horizontal, that passes through the point -8, -7. Now, this would be a line at y equals something, all right, because that's the y is always going to be the same value, whatever it is. The x will change. X will be 0, x will be 1, x will be 2, but the y is always going to be whatever the y value. We want to know when the y equals -7. So y equals -7. Right there. That's the y equals equation. Again, I might even take a practice test to write all these notes. Have notes for your test. You get all your handwritten notes all the time, guys. Use them on your test. Write down little stuff. Write down things that help you and use them on your test. All right, let's identify the slope of the line shown in the graph below. All right, here's the line. What's the rise? The rise is, well, it could be whatever we want it to be. Let's say it goes from here. Say we're looking from here to here. Rise is 2. The run, it runs 0. What's 2 divided by 0? Well, when you put that in your calculator, it's error. You cannot divide by 0. That's when the world explodes and life as we know it ends. Okay, maybe not that drastic, but you cannot divide by 0. So when you have a vertical line, the slope, okay, I'm writing these notes that I could use on my test. Undefined. We cannot define a slope because this is not a number. We cannot simplify that. It does not exist. So on vertical lines, slope's undefined. Horizontal lines, slope equals 0. There's no slope. There's no rise or run. It stays flat. It's a slope of 0. But for this one, undefined. Good notes there for you. All right, the graph of functions f of x and g of x equals f of x plus k. So here's f of x, here's g of x, and they're saying this is the same thing since they're parallel. It's the same thing as taking f of x and adding k to it. If we add k to it, we'll get g of x. So the value of k is what? Well, what did it take to move this graph from here up to there? We took whatever, remember f of x is the same thing as y. Whatever the y is, and we added 1, 2, 3, 4. That's the same thing as f of x plus 4 is the same thing as g of x. That's where g of x ended up. We just added 4 to this graph, and every point would move up 4. 1, 2, 3, there's the new point. 1, 2, 3, there's the new point. Just adding 4 to every y for wherever we're at on the graph. Okay. This graph shows the velocity of a runner during a certain time interval. Meters per second, velocity. So how fast he's going is how many meters per second he's going. Which of the following describes the intercepts on the graph? So here's our y-intercept at 6. Here's our x-intercept at 8. And since the x is time. So this says the initial velocity of the runner was 6 meters per second. Velocity, 6 meters per second. And the runner stopped after 8 seconds. This is time. His velocity went to zero velocity at 8 seconds. Right there, our first choice was right. He started at 6, he ran a little faster, and he slowed down and stopped. Now this says the initial acceleration of the runner is 6 meters per second squared. This is not meters per second squared. And the runner stopped at 8 seconds. So that's why that one's wrong. Initial velocity of the runner is 8 meters per second and stopped after 6 seconds. No, meters per second is the y. So it's not 8. And the same thing here, it's not 8. So make sure you know the x's and the y's. It tells you the y right there is meters per second. All right, let's look at this one. If f of x is the total number of bacteria present in a sample after x hours, so x is the hours, which of the following statements best describes the meaning of f of 2 equals 12? F of 2, f of 2, f of x, right? We're not going to put f of x, but now we're saying the x equals 2. So that means 2 hours. At 2 hours, we have 12. So this says the total number of bacteria present in the sample after 6 hours is 2. No. Bacteria after 6 hours is 12. It's not 6 hours because it's f of 2. The total number of bacteria present in the sample after 2 hours is 12. 2 hours equals 12. That's what we want. Total bacteria present in the sample after 12 hours is 2. No, hours is the x, and it's f of x, so it's x is 2. 2 hours equals 12. Equals is 12. All right, let's move on. Mapping diagrams, like mapping diagrams. -2 goes with 8, so that's talking about the point -2, 8. 0 goes with 1, it's talking about the point 0, 1. If we was making a table, it'd be a table where -2 went with 8, 0 went with 1. Same thing, 5 goes with 3, 7 goes with 5. Is this a function? With the function, each x only gets one y, 1. So did any of these x's get 2 y's? That x only got 1 y. That one only got 1. That one only got 1. That one only got 1. Yep, that's a function. That's a function. Now, don't let it fool you. If it did a mapping diagram and it had 0 and 1, and over here it had 1, 2, and 3, and the 0 went to the 1, and the 1 went to the 1, and it said, is that a function? And you go, well, no, there's 2 here, but it doesn't matter if there's 2 pointing to the same y. This x only got 1, and this x only got 1. It was the same one, but that's okay. They each only got 1, so that's also a function. Doesn't matter that nobody paired up with 2 or 3, and it doesn't matter that more than one used the same y. They each x only got 1. So, okay, down to this problem, a little bit bigger problem. The table below shows the distance in meters that an object travels in t seconds. So t equals seconds. seconds, distance in meters. So after 1 second, it's traveled 15 meters, distance, meters. 3 seconds, 135 meters. Okay. What is the average rate of change of dt, which is distance, between 2 seconds and 4 seconds? And what does it represent? So between 2 seconds, it was a 60. At 4, it was 240. So how much did it change? How from going 60 to 240, 240 minus 60 is 180. So that's the distance in the y's. That's how much it changed. How the x changed? 2 to 4. 4 minus 2 is 2 seconds. So it changed 180 in 2 seconds. It went from 60 to 240. So that means that simplifies 180 divided by 2 is 90. So that was the average. It traveled an average of 90 meters per second. Okay, so what does that mean? 90 meters, 50. It's not 50. Because we see it went from 60 to 240. It changed 180 in 2 seconds. So these two are both out because it has the wrong meters per second. So these both have the right meters per second. This says it represents the average speed of the object between 2 and 4 seconds. And this says it represents the average distance traveled. Meters per second. This is meters per second. Meters per second is a speed. It's a speed. So it's averaging 90 meters per second. See, 90 meters per second. If this just had answers of 90 meters, well, that would be a distance. But that's not the average. It says 90 meters per second. So since it says meters per second, that's speed. If I give you a ruler and say, how big is this line I drew? You're not going to say it's 6 inches per second. All right? You're going to just give it that. So per second is speed. So let's look at this one. Choose the equation that represents the graph below. Okay, so we have this graph, and we have 4 equations that are in the y equals mx plus b, right? M is slope, b is y-intercept. Slope, y-intercept. Okay, hope you remember that. That was back in junior high, middle school. The m is the slope, b is that. So what is the y-intercept? Where does it intercept the y-axis? Where does it cross? Right there. So it should be a +4. That should be the end of the equation, the b. This is -4. This was -4. We've got it down to those 2 equations. So what is the slope? Well, let's find where it crosses a point at. It crosses right there. That's not on a point. That's not on a point. That's not. Here's a point right here. So what did it do between those 2? It went down 1, 2, 3, 4, and it went over 1, 2, 3. So it went down 4, +3, -4, +3, -4/3 is the slope. That is this one right there, gives us the equation we're looking for. All right, let's move down to number 17. We're moving right along. If f of x equals 2x squared minus 10, find f of 5. F of x, f of 5, so the x became 5. So x equals 5. So what does this equal if the x equals 5? Well, 2, let's see, f of x equals 2 times x squared. 5 squared, because x is 5, minus 10. So f of x equals 2 times, what's 5 squared? Well, when you square something, you multiply it by itself. So that's 5 times 5. 5 times 5 is 25. Okay. So now we've got to 2 times 25 is 50. 50 minus 10, f of x equals 40. Right there. So f of 5, sorry, that's not f, let's make it f of 5. F of 5 equals 40. F of x could be anything depending on what x is, but f of 5 equals 40. Okay, a telephone company charges a fixed monthly rate, so that never changes, plus a rate per minute. So the company charges $120 for 100 minutes of usage and $95 for 50 minutes of usage. So an equation can be written to show the relationship between the total minutes used, which is the X, and the total monthly charges, which is the Y. So which best describes the steps to draw the graph? So we're talking about some points, and it says the X is minutes used. X is minutes used. So let's look at this one. 100 minutes for $120. It told us that X is the minutes. X is the minutes. So that would be, it's the point, that's the X. And the total monthly charges, dollars, total monthly charges is dollars, is the Y. So $120. That has to be the order of those two. Over here, we've got the minutes, the dollars, right? So that's the 2 points. So it says draw a graph which join the points 100, 120, and 5095. 100, 120, 5095, 120. These are backwards. So we've already ruled out the bottom two answers. And has a slope of 2 or 1/2. So what would the slope between those two be? Well, remember, to find the slope, well, not M, I mean not Y, let's do M. M is the slope. It's the difference in the Y's, Y2 minus Y1, X2 minus X1. So our first and second Y's, Y2 and Y1. So Y2, we can choose either one of them to be Y2, but whichever one is Y2, that means its X is X2. So let's make the bigger one Y2. So 120. And since that's the Y2, this has to be the X2. So the 100 goes underneath it. Minus the Y1. So this is going to be the other Y, 95, which means that has to be the other X, minus 50. So what's 120 minus 95? That's 25. What is 100 minus 50? That's 50. So the slope is 25 over 50, which is the same as 1 over 2. So it's a slope of 1/2. Slope of 1/2. Notes. Make notes, guys. All right. If h of x equals negative 3x minus 10, find h of negative 3. X, negative 3. So h of negative 3 is going to equal negative 3 times, instead of x, we know x equals negative 3 minus 10. So negative 3 times negative 3. A negative times a negative is a positive, minus 10. So it equals negative 1. Because 9 minus 10 is negative 1. All right, let's move on. Getting closer to the end. All right, the graph of the function f of x is shown below. And it's not a connected graph. This is a discrete graph. It's not continuous. Continuous means we can draw it with the pencil without picking up off the paper. Discrete means we have gaps. So this does not include anything where x equals 1/2 or x equals negative 1/2. It only includes where x equals negative 1, 0, 1, and 2. So this would be something like a quantity of something, but we couldn't have a negative. What is the domain of f of x? Domain. We have domain and range as the two terms we use. Again, notes for your test, guys. Domain is all the x's. Range is all the y's. So what are the x's? We have an x of negative 1 right here. We have an x of 0. We have an x of 1. And we have an x of 2. That's all the x's. So our choices are integers. They're all integers, which means it's not going to be a fractional number. It can't be 3/4. It can't be pi. It can't be negative 1/2. It's not going to be 0.2. Integers are only numbers, actual counting numbers. It could be a negative, but it's a number. It's not a fraction. So integers from negative 1 to 2. Ours goes from negative 1 to 2. Negative 3 to 3. Negative 3 to 3. Negative 1 to 2. We have two choices to have negative 1 to 2, which is where we go from. The negative 3 to 3 is going up and down. Negative 3 to 3. That's the range. That's the range. It didn't ask us the range. So the difference is this: less than or equal to, or just less than. So if it's equal to, that means it includes that number. Does our domain include -1? It does. We have a point at -1. It includes it. So it has to be this one. This one says anything bigger than that, but not including that, and anything smaller than that, but not including that. Ours includes those numbers. So that is our answer right there. Okay, choose the equation below that represents the line passing through the point -5, 1 with a slope of 3/2. Okay, this is the point slope formula. Remember, y minus whatever the y is equals the slope, then x minus whatever the x is. Okay, whatever. This is your point, and this is for the point x1, y1. That's how that works. This is the point x1, y1. That's the equation. So if our point is -5, 1, and our slope is 3/2, m equals 3/2. If we substitute these in, y minus the y1 is 1, equals the slope 3/2 times x minus -5, right? That's what the x1 is. The x1 minus a negative means we add it, so it'll be x plus 5. Which one of these equations is that? Looks like it's the first one right there, right? Y minus 1, 3/2, x plus 5. This has the wrong numbers, and this has the wrong signs. So, first one. All right, number 22. How many do we have? I think we have 25. We got 2 pages left. Okay, here we go. The domain of the following relation. Domain. Let's see, we said that's the x's. So what are the x's of this relation? Not a graph. This is just listing the points. So this one's -3, and then we have 5, and then we have 1, and then we have 2. Oh, 5, we've already listed 5. It's already in the domain. We don't list it twice. We're just saying, what are all the x's? It doesn't matter if we use them more than once. We can use the x's as many times as we want to, but we only list it in domain once. We have 1, 5. So there's our domain. No, this lists the 5 twice. We don't list the 5 twice because we're just saying what all x's are there. Well, we've already named it. We don't have to name it again. No domain. There's obviously a domain because there's obviously x's. -3, 1, 2, 5. Generally, when you list a domain, you're going to list it in order, smallest to largest. -3 is the smallest one. The next smallest one is 1, and then 2, and then 5. So this is our choice. List them smallest to largest. Same thing with the range. Domain and range, you list them smallest to largest. All right, the tables below show the values of y corresponding to different values of x. So when x is 3, y is 1. When x is 3, y is 0. When x is 2, y is 0. Table B is when x is 3, y is -2, 5, 2, 5, -2. Which statement is true? Both table A and table B do not represent functions. Okay, so we're talking about, are they functions? So let's look. Is this a function, table A? Does every x only have 1 y? Did any x go back and grab a second y? This x, 3, got 1. Oh, and then it went back and got a second helping. Not a function. Because this x appears twice, which means it went and got 2 different helpings. It got a 0 and it got a 1. So this is not a function. 3 got a -2. 5 got a 2. Oh, then 5 went back and got a -2. Neither one of those are functions. Because 5 is listed twice, 3 is listed twice, and it only matters in the x's. This is fine. The fact that we have zeros, that's fine. Because it's the y. We don't care about the y when we're checking to see if it's a function. We don't care about the y's. Only is there x's listed twice, which means it got back in line and got another y. This says table A is a function, table B is not, but table A is not a function. It says both of them are functions, and this says table B represents a function. So that's why those are wrong. Neither one of those are functions. All right, last 2 problems. Oh, it's actually just one problem. Great. Last problem. The graph shows 4 straight lines, P, Q, R, and S. Which line is represented by the function f of x equals 4x minus 3, which is the same thing as saying y equals 4x minus 3, which means this is in the y equals mx plus b form, which means slope, which means y-intercept. Well, they all have the same slope because as we can tell they're parallel. They all have a slope of 4. See, this goes from 3 up 4, 1, 2, 3, 4, and over 1. So it goes from there to there's a slope of 4. They all have a slope of 4. But which one has a y-intercept of -3? Here's 0, -1, -2, -3. This is the only line right here that has a y-intercept of -3. So it has to be line S. Don't just choose the last one. Look, these are not in the same order, R, Q, S, P. We want line S because it has the right y-intercept. That's the only difference. You're looking for that y-intercept. None of the others cross the y at -3. All right, that's it. Like I said, take good notes. Use them on your test. Write down some of these things that you don't always remember. And, if you want to print out the practice test and go through it, if you print one, you'll probably have some different questions than this, but they should work the same way, just different numbers. So, all right. Do your best, everyone. Do work you can be proud of.